Hey, what's up, everybody? I'm Divya. Welcome to Visual Vibes. In this Python course, I'm gonna teach you everything that you need to learn to start coding with Python. This course doesn't cost you anything, it's totally free for you. But if you would like to help me out, then you can increase its reach by hitting a like button, leave a random comment down below, share, and subscribe to my channel for more videos. Thanks in advance, and I really appreciate it. Without getting any delay, let's jump right in. Today we will be seeing two interesting topics in Python that includes recursion and iteration. So before I get started, I would like to tell you one thing. If this is your first visit to my channel or if you are a beginner to the Python course, then I would like to highly recommend to check out the earlier sessions of this video first before you watch this video and then circle back here for a deeper understanding before getting into the newer concepts and to follow some sequence. So now let me first start with the recursion. So recursion in So up to now, we have seen how we can define a function and how we can make a function call by passing arguments as well as passing function to another function. But we haven't seen the case where function calls itself. So that will happen in the case of recursion. So recursion in Python is simply a programming technique where a function calls itself in order to solve a problem. So what it will do means to solve a particular problem, first it breaks down the problem into smaller and simpler sub-problems by calling a function itself until a particular condition is satisfied. So recursion in Python is having two key components that includes recursive case and base case. So recursive case is the case where the function calls itself with an input. So wherever in our code, wherever we have the part where the function is calling itself by passing an input. So that case we can call as a recursive case. So in this recursive case, what it will do means it will break the problem into smaller sub-problems by calling the function itself by passing an input to the function. So base case is the part where the function stops calling itself once a particular condition is satisfied. And it prevents infinite recursion, giving directly the result. So whenever the condition is not satisfied means the function will keep on executes, right? And it will not end. That results in infinite recursion. So in that will not be the case in case of recursion. So base case is the case where it prevents the infinite recursion. And when it comes to working, first of all, it pauses the current function and it stores the current state in memory called call stack. So whenever if a new function is called, the current function execution will be paused and it will store the current state in a memory called call stack. After storing that current state, it starts executing a new function call and it will keep on executes the function call. So once the base case is reached, the function returns values back from the stack. So once the base case is reached, it means like this is the case where the condition is satisfied and the function stops calling itself, right? So whenever that case is reached means then the function automatically starts returning back the values from the stack. So this is how it works. Now let's see the examples. So in order to demonstrate the recursion, I have given two examples that includes factorial as well as sum of natural numbers and their visual flows, how the actual flow will go. Now let's see first of all the factorial of a number. Basically to find out the factorial of a number, we are using here the recursion concept. So generally factorial of a number is the product of all positive numbers starting from 1 up to that number, right? So in order to find out that factorial of a particular number, here I have defined a function named factorial where I was passing a number as a parameter to this function. And inside this function, I was checking if n is equals to 0, I need to return 1 because factorial of 0 is 1, right? So whenever n value becomes 0, I want to return 1. So whenever n value becomes other than 0, in those cases, I would like to find out the factorial of that particular number. So factorial of that particular number will be n into n minus 1, right? Generally, n into n minus 1, how we can calculate if we want to calculate the factorial of f3 means, then how it will be 3 into 2 into 1. That means 3 into n minus 1 and into again n minus 1 of that particular number. So like that, here also we need to calculate n into factorial of n minus 1. So means in order to calculate the factorial of that particular n minus 1, again I was calling the same function. So this is what recursion means. In order to find out the factorial of n minus 1, I was using the same function call again and again. So the function call is getting repeated again and again. So this is what all about recursion. Here the function is, here we have a function. This function is calling the function itself again and again. So this is how recursion works. So here I would like to calculate n into factorial of n minus 1 by calling this function. And finally, I would like to return the value. And in the sixth statement, I would finally I was printing the result of that particular function, result of that particular factorial of a given number. So output will be 6. So now let's see if I want to calculate the factorial of 3 means how the visual flow will looks. Instead of explaining it here, so it is getting easy. It is easier to understand this visual flow so that you can very well understand this example. So here, in order to calculate the factorial of a 3 number, first what it will do means, so whenever I call this function factorial of 3, so if this function call will happen by passing the value for n as 3, then inside this function call it will check if n is equals to 0. So no, n is not equals to 0, then it falls under else part. And then we have a return keyword followed by n into factorial of n minus 1. N is 3. N is 3. Factorial of n minus 1 means 3 minus 1, 2. So it will be 3 into factorial of 2. Factorial of 2 means here, factorial means function. And inside this function, so we are passing again the value to this function. That means this function call will happen again. So again, so before this function returns this value, it needs to evaluate this value, right? So in order to evaluate this value, we need to know the value of factorial of 2. We don't know the factorial of 2 because this function should return finally the value. Then only we can be able to return finally the value of return final result back to the function call. So what it will do, 3 into factorial of 2. Again, what will happen? Again, this function call will happen. So factorial of 2, it will check this condition. The condition becomes false and then it will fall under else case. And then again, it substitutes the value n into factorial of n minus 1. So this time the value of n is a 2, 2 minus 1, 1. So 2 into factorial of 1. And again here we are calling the function again by passing the value 1 to the factorial function. So again the function call will happen. It will fall under else part and then it will substitute the value 1 into factorial of 1 minus 1 will be 0. So the factorial of 0. Again this function call will happen. So now this time the value is 0. So n value is 0. So here this condition is satisfying now. N is equals to 0. So if n is equals to 0, what we are returning? We are returning the value as 1. So what it will do means, so in place of factorial of 0, we are directly returning 1. So in place of factorial of 0, 1 will be substituted. So 1 into 1 is equals to 1. So this 1 will be returned back to the factorial of 1, right? Up to here, the forward recursion is happening. So once it will be able to evaluate the factorial of last number, then it will start substituting the value, right? So then it will, from this point onwards, it will do the reverse calculation. So up to now these values are these values will be stored in call stack. So whenever we have a value that is available, which is a factorial of 0 is available, then it will start substituting the value so that it will get the result one by one from that call stack and it will start substituting. So that's why 1 into factorial of 0 will be in one value is written, so 1 into 1, 1, and this one value will be returned back to the factorial of 1. So that's why reverse substitution will be happen, and then 2 into 1. So this factorial of 1 will be 1. That is equals to 2 into 1, 2. And again, this value is returned back to the factorial of 2. So that's why in place of factorial of 2, this value will be substituted. Then 3 into 2 becomes 6. So finally, the output, it will return back the result as a 6. So like this, recursion will happen. Like it's keep on executing the same function again and again until a particular result is returned or particular condition is satisfied. So this is about factorial. Like this is about how recursion works in terms of for a factorial in order to find out a factorial of a number. So to find out the sum of n natural numbers, how recursion will happen? Let's see in this example. Suppose I would like to find out the natural sum of all the natural numbers. Let's say suppose if the n value is 3 means sum of all natural numbers will be 1 plus 2 plus 3, right? Or else 3 plus 2 plus 1. Up to that number, we need to add the sum of all natural numbers. Let's see the example here. So here I have defined one function named as sum underscore natural number. So this will take a number as a parameter to it. Here, if the n value becomes 0 means um, whenever we will add, whenever sum of all natural numbers means 0 plus 1 plus 2 plus 3 means 0 will, now we have a no value for the 0, right? So whenever n value becomes 0, I would like to, so I want to return the value as zeros. Else I would like to return n plus the sum of n minus 1. So else I would like to return n plus n minus 1. So suppose that the value n value is a 3 means up to that number we would like to add all the numbers back, right? So 3 plus 3 minus 2, 1. Like that we need to add, right? So the likelihood that n plus sum of n minus 1. So this is case, this comes under recursive case, and then finally function call will going to happen by passing the value to the function. Now let's see the visual flow of it. So here for the function sum underscore natural, I was passing the value as a 3. So initially, whenever this function is called, 3 will get substituted here, and so n is not equals to 0, so it falls under else case, and then it will try to evaluate this value n plus 3 plus sum of natural 3 minus 1 2. So here function call is going to happen, right? So again the function call will happen here. So 3 plus sum of natural of 2, function call will happen by passing the value to the this function, and then again 2 plus sum natural of this time. Once 2 value is passed, it checks this condition and falls under, so condition becomes not satisfied, and then it falls under else condition. So 2 plus 2 minus 1. 1 now this time 1 will be passed to this function. So like this it keeps on continuous. Finally 1 plus the sum of natural number 1 minus 1 1, 1 minus 1 0. So at last to this function 0 is 0 will be passed. So this condition will be satisfied. So since this condition is satisfied, it returns 0 back, and then since this function is returning a value back, so it will, the function, this expression is evaluated, and then value is returned back as a 0. So this 0 will be substituted in place of this. So 1 plus 0 will become 1, and this 1. So from this onwards, from this onwards, it starts calling the results back from the stack, call stack, and then it will substitute the values. So 1 is returned back. So here we have a 2 plus sum of natural of 1. So in place of this, we have this value. So this value gets replaced, and then the result will be 3, and then this result will be passed to the sum of natural number of 2. And so finally, this value will be, this 3 value will be substituted in place of this expression 3 plus 3, and finally the output will become 6. So like this recursion will happen whenever we want to find out the sum of n natural numbers. So in order to demonstrate the concept of recursion, I have explained these two coding examples for you. But you can apply this recursion concept wherever needed in real world scenarios. So suppose wherever we have a condition that keeps on executes the function itself, and finally if we want to stop set particular condition, then we can make use of this recursion concept. Iteration. So we have already seen this iteration, how this iteration works in our previous sessions, but we haven't discussed theoretically in detail. Now let's see how this iteration, what this iteration is all about, and how this works well. So iteration is simply nothing but is the process of looping through the elements in a collection. So this collection is nothing but we can have a string, list, tuples, and dictionary, like all sequence data types that are having a collection of elements. we can make use of this iteration. So it's simply nothing but looping through a collection of elements. And we have two properties that comes under iteration. One is iterable and iterator. So iterable is nothing but it's a collection, or I can say it's a simply an object which can be looped over. So here we have a collection, right, that includes a string, list, tuples, dictionary. So this all these collections I can call as an iterable. Why means this is a collection where we can loop over. And the next one is iterator. So Python makes use of this iterator in order to loop over the collection of elements. So in order to loop over the collection of elements, this iterator will use two methods. One is iterator method, and the next one is next method. So what this iterator method will do means whenever Python calls this, whenever Python wants to iterate through a collection of elements, it makes use of iterator object. So it first calls this method, so that returns the iterator object, and this iterator object, with this iterator object, whenever it calls the next method, that returns the items one at a time. So with the help of this iterator and next methods, Python will try to iterate over a collection of elements. So here I have given example where Python works behind the scenes like this. Suppose if we have a iterable object like this, where we have a list here containing 1, 2, 3 elements in it. So whenever, according to our code, Python compiler will execute, right? So whenever it's going to execute, if it wants to iterate over a collection of elements, then it will first create the iterator object by defining it like this. I'm saying this will all happen behind the scenes. Python compiler do all these things behind the scenes. Okay, so first it will create the iterator object by passing that iterable list iterables, and then it will try to loop over or try to fetch the items one at a time with the help of next method by passing this iterator object. So like this, whenever it calls the next method by passing the iterator object, this will return the element one at a time. So whenever this iterator is next method is called by passing this iterator object, so initially it will returns the one element, next it returns next element, next it returns next element, and so on until that list is going to be terminated. So like this, Python will make use of iterable and iterator in order to loop over a collection of elements with the help of this iterator and next methods. So when it comes to coding, like how this iteration are actually going to work in case of list, strings, and over a range of numbers and over a dictionary, I have given one example in order to show you how this iteration works. So here, first one is about iteration over a string. For example, if I want to iterate over the characters in a particular string using the for loop, we can be very well iterate using the for loop like this, like for each and so in this string, I would like to iterate. So that's why I have given for loop here by for, and then a variable which is used to access one by one character, and then which is useful for iteration. And then I was printing inside this function, not function, inside this loop. I'm printing the each and every character. So this is how we can iterate over a string. If you want to iterate a range of numbers, so we're gonna make use of built-in function named a range, and by passing the range to it. So I would like to iterate over 1 to 5 numbers. So I am giving the range over here. What are you doing? And then finally, if I want to iterate over a list, so I have given the list here, a list of file elements. Here I was iterating one by one elements in the list with the help of using while loop. So initially I have declared a variable called I is equals to 0, and then I would like to iterate over this list by the help of using while loop by giving the condition like this, I less than length of that list. And inside this while loop, I would like to print each and every element which it was looping, and then finally we need to incrementation is going to happen, right? So that's why I was incrementing the value of I one by one. So like this, it will keep on iterate one by one element in the list, and then it will print the result. Suppose if you want to iterate over a dictionary, so we can use while loop. So like this, it will keep on iterate one by one element in the list, and then it will print the result. Suppose if you want to iterate over a range, so we can use while loop. So like this, it will keep on iterate one by one element in the list, and then it will print the result. Suppose if you want to iterate over a dictionary, We can make use of same for loop also, same for loop, and then in order to iterate over the keys as well as values in a dictionary, we can make use of this items method, which is present for a dictionary. So that's why I have defined two variables, and then I was calling this items method uh, that is available for a dictionary, and then I was printing finally the key value pairs. So like this, you can iterate over one by one character. You can iterate over a range of numbers. You can iterate over a collection of elements in a list, and you can iterate over key value pairs in a dictionary. So like this, this is how iteration works. So this is all about recursion and iteration. So that's all for today. I hope you like this session. If you have any doubts, feel free to post them in the comment section. We'll definitely answer your questions, and I will see you in the next video. Until then, take care, goodbye, and enjoy programming.